In this video, we're looking at another example of finding a volume of a solid using cylindrical shells. So we've got the curves x plus y equals 3 and x equals 4 minus y minus 1 quantity squared, and we want to go about the x-axis in this case and find the volume of that solid of revolution. All right, so again, to talk about why we want to use shells versus using washers, if we were going to use a washer, we would have to slice perpendicularly to our axis of rotation. Our axis of rotation in this case is the x-axis. If we go perpendicular, we're going to have to do a top and a bottom curve. Notice the top curve stays the same throughout the whole thing, but our bottom curve changes. As soon as that bottom curve changes, we know we would have to do multiple integrals. It'd be much simpler, hopefully, to do one integral as opposed to two. So it would be much easier in this case, theoretically, to integrate with respect to y versus with respect to x. Also notice that our second function is given to us as a function of y, which means also it'd be much easier, hopefully, to integrate with respect to y than with respect to x. But when we do an integral with respect to x, I would have to solve that equation for y. So both of those things are pointing towards the fact that we want to integrate with respect to y. So if I slice up the y-axis, my slices now are parallel to our axis of rotation, which means we're going to get shells, which is what this purplish, magenta-ish color here is over here. We're going to get shells rather than washers. So to find the volume of a representative shell, I needed the radius of the shell and the height of the shell. Well, again, the axis of rotation is the x-axis, so going radius in this case, we're going to go from a y-coordinate to 0, so the y-coordinate is the radius. So that's where the 2 pi y is coming from. For the height of the shell is given to us by the difference in our right curve and our left curve. The length of this segment here will be the height of the shell. So that's where we're doing right curve is the parabola, left curve is the line, and I forgot a right parenthesis here. Doing a little housekeeping here, multiplying all this out, multiplying the y through, pop the constant out in front. We should get 3y squared minus y cubed for our integrand. We need our limits of integration. These limits of integration, again, are going to be in terms of y, because we're integrating with respect to y. Set the two functions equal to each other, and solve. We should get 0 and 3 for our solutions. And we can see that here from the graph. Here's y equals 0. Here's y equals 3. So going through, finding an antiderivative for our integrand, plugging in our endpoints, and simplifying, we should get 27 pi over 2. Again, remember the big thing here when we're using shells is we need a radius and a height so that we can use 2 pi times the radius times the height times the thickness to give us the volume of that particular shell. And then the integration is what adds all of those volumes together.